This is not a computer game. What you are looking at is a 4-node high-performance single system image cluster. It is real-time load balancing a distributed parallel chess engine by utilizing a technology known as live process migration. This video is brought to you by the MattX project, and my name is Matt Reschenberg, the head of development. We have just released the brand new MattX version 1.7, and this video is here to give you a deep dive into exactly what MattX is, how it works under the hood, and how it can transform your infrastructure. Inspired by the legendary openMosix project, MattX allows multiple physical or virtual machines to act as one massive unified computer. It autonomously load balances CPU-bound tasks by seamlessly teleporting running Linux processes across the network. When a process migrates, MattX preserves its entire memory map, its CPU registers, its open file descriptors, and even its active network sockets. And the best part? It does all of this without requiring any modifications to the Linux kernel source code and without requiring you to rewrite a single line of your application. No recompiling, no linking against complex MPI libraries, it just works. MattX seamlessly transforms a bunch of nodes into a supercomputer, simply by loading a kernel module and starting a user space daemon. On the administration, management, and especially on the process level, this creates the perfect illusion of one single computer with as many CPUs as you have cluster nodes. This means your unchanged multi-process HPC application are automatically load balanced. The processes don't even know that they have been clusterized. They just wake up on the new node and keep calculating. To prove this, what you are seeing right now is a 4-node MattX cluster playing distributed parallel chess against itself using our custom PVM chess engine. PVM chess calculates the best possible next move by evaluating massive decision trees. To do this, it rapidly spawns 15 to 20 separated chess client processes to evaluate different branches of the game. On a normal computer, these processes would fight each other for CPU time, bottlenecking your system. But with MattX, our built-in load balancer detects the CPU spike, it instantly grabs those running chess client processes, freezes them safely, and teleports them across the network to the idle nodes in the cluster. The result? The chess game runs about 3 to 4 times faster using a 4-node MattX cluster than it does on a single computer. Now you might be wondering about these visuals. We built the 3D MattX spaceflight cluster monitor and the 3D wormhole viewer because standard terminal output just doesn't do justice to what is happening inside the kernel. In the wormhole viewer, every silver sphere you see flying across the chessboard represents a running Linux process which is being tunneled across the cluster. We went with this aesthetics because we think the C in HPC stands for cyberpunk. But let's get technical. Let's talk about how MattX handles the hardest part in clustering: data paths and scalability. When a process migrates to a remote node, it still needs to read its files and talk to its network sockets. To solve this, we built MattXFS, a cluster-wide virtual file system. When a process lands on the new node, MattX traps it inside a private Linux mount namespace, a glass box. It bind mounts the remote MattXFS tree directly over the process's root directory. This creates the namespace illusion. The process thinks it is reading a local file, but the Linux virtual file system natively routes that read operation across our TCP wormhole back to the home node. Every node sees every other node. But we have designed MattX with a massive focus on scalability. Sending heavy file I/O over the TCP wormhole can be a bottleneck. That is why MattX allows you to become the architect of your own data paths using our configuration toggles. In your MattX conf, you can toggle migrate network I/O and migrate file I/O. But the real powerhouse is the DFSA directory to configure the direct file system access. If your cluster shares a SAN or an NFS drive, you can configure MattX to bypass the network entirely. The namespace illusion will bind mount the local SAN directly into the migrated process's glassbox, allowing it to read and write shared data at bare metal speed. MattX perfectly adapts to any custom HPC scenario, scaling from 2 nodes up to more than 500 physical servers, virtual machines or cloud computing instances. And you have the complete real-time control over all of this. MattX embraces the Unix philosophy. Everything is manageable via the MattX proc interface. You can view your connected nodes, check your cluster load, or manually teleport a specific process to a specific node by echoing a command into /proc/mattx/admin. So what is new in MattX version 1.7? Why is this release so special? In 1.7 we completely re-architectured the system to separate the control plane from the data plane. We introduced the Kworker plus Native Injector architecture. Instead of violently waking up the original sleeping process on the home node to handle remote system calls, MattX now spans background kernel threads. These Kworker execute your file and network operation natively inside the kernel, and then forcefully, surgically inject the resulting file descriptors directly into the sleeping process's memory. It is silent, it is native, and it's blazingly fast. And because of this new architecture, perfectly mimics standard local Linux process behavior, we achieved something incredible. MattX 1.7 is now fully supported on RPM-based distributions like Alma Linux. And the best part, MattX runs flawlessly even with SELinux set to enforcing. SELinux inspects your Native Injector, sees perfectly valid kernel credentials, and lets it right through, completely unaware that the process is actually being puppeteered across a TCP wormhole from another machine. If you are watching this and thinking, this looks amazing, but clustering is too hard to set up, I have great news for you. A massive shout out to openMosix legend Chris Buitard, who recently contributed the official MattX test suite. Using libvirt and official cloud images, this suite fully automates the deployment of a MattX cluster. With a single command, make dep cluster, you can spin up a fully configured multi-node MattX development environment in under 5 minutes. It currently supports Debian and Alma Linux right out of the box. And if you are asking yourself right now if MattX supports the absolute bleeding edge of Linux, the answer is yes. Everything you see in this video is running on MattX 1.7, and we are already fully supporting the new Linux 7.x kernel series. We are incredibly proud of what this project has become, and we are proud to state that MattX is completely open source and released under the GPL version 2 license. I hope you enjoyed this deep dive into MattX. Many thanks for watching. If you found this interesting, please try it out yourself. You can find MattX, the 3D visualization tools, and a link to the MattX test suite on our GitHub page. Enjoy MattX and keep on clustering!